Hello everyone, and thank you for joining me. I'm John Rotenstein. I'm a developer advocate at AWS, which means I'm here to help you folks who are developers learn to use AWS. And we have this weekly show where we are aiming at people who are fairly new to AWS and want to learn how they can develop against the AWS services. Georgia, fantastic. We've got some people from San Francisco and Sydney as well. That's great. So this week we are focusing on building and deploying Lambda functions. Next week we're not on because there is a special event running out of this time zone on the AWS Twitch channel. But then we're coming back with cloud security fundamentals. Everything you need to know, well, not everything. Everything we can fit in an hour of what you need to know for cloud security. And after that, in September, we'll have a show on containers, and this will continue each week on various different topics. So I hope you can join us for each of them. Computer Pros in Brisbane, fantastic, and Ravi from Auckland, excellent. I heard that Auckland just went down a bit more lock-in, which is a bit unfortunate, a bit like Melbourne here in Australia. So I figure we should probably kick things off with an example. You know, there's nothing like actual playing with things to understand what you can do. I have here in my S3 bucket in S3 I have a few buckets, and I will point out two buckets here. One I have called Let's Code Lambda, and one called Let's Code Lambda Resize. And I'll use these to give a very simple example of how you can use Lambda. My two buckets are empty. You can see both of them are empty there. I will now go and upload a picture. Let me find a nice picture here. Maybe some cheese, some Shalahocka cheese. Making me hungry already. Will you be able to rewatch this on YouTube? Yes, I'll be uploading this to YouTube. If you search for AWS developers Let's Code, you should be able to find it on YouTube afterwards as well. So this is a picture of some cheese. If I show you what it looks like, nice big picture of some, looks like a fairly hard cheese there, which is great. And here is the resized bucket that I showed you before that is empty. But if I hit refresh now, you'll notice that a new file has been added. When files are added to S3, we call them objects because they are immutable. So files and objects means the same thing, but when something's in S3, we tend to call it an object. And you'll notice it has the same name. And if we look at the upload times, let's go to this one. I uploaded at 11:01:47. This is Sydney time, 11:01:47. And this other file was created at 11:01:50 seconds. So 3 seconds later, this file was created. And if I have a look at what's in this file, it is a resized, a tiny piece of cheese, little baby cheese. And that was done with Lambda. So by uploading a file, it triggered a Lambda function, caused it to resize and store the thumbnail picture in another bucket. What does the code look like? It's fairly simple. Here is the code behind the scenes. Lambda calls this function, and the function says, get me the... we pass through something called an event. An event is everything Lambda needs to know about what happened. Traditionally, most Lambda functions are triggered by something. Lambda does something in response to that event and returns or does something and exits. And sometimes it only runs for a few seconds or even a fraction of a second. So in this case, the Lambda function is saying, I was triggered by S3 because a new file was uploaded. I'll show you how you can do that. This is the file name or the key of the file that was created. It then says, hey, download that particular object for me into my temp directory. Lambda has a temp directory where you can store up to 512 megabytes of data. Resize the image and upload it again. And the resize code is pretty simple. It's using a library called Pillow, and it simply said, open the image from the local disk, resize it to 128 pixels, save it again, and upload it. So nice, simple example. So let's try that again. We go into the S3 bucket. Let's upload another picture. Maybe a garden scene. So there is the garden. It was uploaded at 11:04:26. If I go to the other bucket and refresh, 11:04:28. So 2 seconds later. And if we have a look at this garden picture, it should be a really nice little thumbnail. So really easy to trigger code in Lambda. So let's go behind the scenes and show you some, first I want to show you some use cases. Oh, by the way, that example I just showed you of resizing is available on our website in the documentation pages. I'll put it here in the chat for you. There's a walkthrough which will take you and show you how you can configure exactly that function. And it's available in a number of different languages. Here it is in Node doing that. There's also a link to same function available. So there's Node. We've got Java, a bit more verbose, and the Python one that I used. I'm a bit more of a Python person. So what can Lambda do? Here on the Lambda page, we give you a few use cases of what you might want to do with Lambda. Let's take a look. Very similar to here. A photograph is taken, it's uploaded to S3. Lambda is triggered and Lambda can resize the photo for you. Really good for making thumbnails for your websites, for example. Or maybe you have Amazon Kinesis. Kinesis is our real-time streaming service where data can be streamed into Kinesis. A Lambda function can then look at that data that is coming through real-time in Kinesis and make decisions. Maybe in this case, it wants to add some hashtag data. Maybe it wants to trigger an alert, store things in Dynamodb, etc. Maybe you want to do some web applications. So here, a weather application running in S3 calls out to API Gateway. API Gateway is our high-scale service that can front-end an API, and it can point to Lambda. So when somebody from a web page calls an API, maybe they're saying, what's the weather? It triggers the Lambda function. The Lambda function returns information. And even IoT devices. Maybe you've got a tractor that's sending sensor information out to our IoT service. Streaming that data through, Lambda can make decisions about what's going on there. So many different use cases are available. So let's jump straight into creating a function so you can see how simple it is. I come here into my Lambda dashboard. My Lambda dashboard is saying, oh, I've got some functions created. I can see how long they ran for. You'll notice a lot of these just ran for under 1 second. So the great thing about Lambda, you only pay for the amount of time that it runs, up to the nearest 100 milliseconds, which is great. And I can see how many times it was invoked and if any errors came through, etc. I will come and create a function. I will call this function just log because I just want to show you what comes through to a Lambda function when it gets created. You can choose your language. Lambda supports a number of languages out of the box: Go, Java, Python, Ruby, .NET. You can also add additional languages using something called a bootstrap. So you can configure your favorite language to automatically load when the Lambda function loads in what's called a layer. And so other languages can be supported as well. I will choose Python. You can attach permissions to your Lambda function. So if a Lambda function wants to call an AWS service such as S3 to get some data out of S3, it needs a role. I create the function. And down here we have an editor. This is using something called Cloud9, which is a great web-based editor. And I think a nice simple function is in order. I have one here, which is probably the world's simplest function. It says, my function is, does it support PHP? Ooh, let's verify whether it supports PHP. Asks Valjitani. I don't think it does out of the box, but let's verify here. PHP, no, not PHP. You could theoretically get it going. PHP is not a great language for from a security perspective. I often hear people saying you shouldn't use it. But if it's your language of choice, see if you can get it going. Let's do a quick check. Lambda PHP bootstrap. Lambda custom runtime for PHP. So yes, if you do a search for that, you can load up PHP and probably get it going. Got to do some funny things to get it in there. So back to this function. When you run a Lambda function, it passes in something called an event. And that event contains information about what triggered the Lambda function. And I can give you an example here. Let's say I want to trigger something from S3. If S3 puts an object or something put an object in S3, it will pass through a lot of information to me, such as which region was it in, what time did it happen, What was the bucket name? What was the name of the object that was uploaded into S3? And from that, you can read the file and manipulate the file and read the contents, etc. Or maybe we want to do something with SQS. So it's SQS, our simple queuing service. If you have a process that puts information into a queue, you can automatically trigger a Lambda function to process the message in the queue. And the great thing about that, you could be throwing thousands of messages in that queue, and lots of Lambda functions can spin up in parallel processing that information. So in this case, the message from SQS comes through, the body of it, the attributes, and you can see which queue triggered that particular function. You can then process it, and Lambda will then automatically delete the message off the queue once it's been successfully processed. So lots of different services here. Alexa for that interactive discussions. Lex, which is a nice chatbot. Let's think of another one that we might have here. We have code commit. I have a sample code commit. So this is when somebody maybe checks in a file into the code commit repository, which is a Git compatible repository. It can trigger an event. So maybe Lambda will go off and build the code or run some testing against it. Load balancers. Lambda can, I don't know if you can trigger. Yes, you can trigger from a load balancer. So if people are accessing your website and they're hitting a load balancer, rather than going to an Ec2 instance, the message can be passed through to Lambda, and Lambda will process that web request for you. And API gateway is another one. This is where API requests coming through API gateway can trigger the Lambda function. G'day, Brads. Good to have you along. So in this case, what I might do is create an SQS queue. I will create a queue. And since Brad's just joined us on the thing, I will say that my queue is called Brad's, and I'm just going to use all the default values and create the queue. If I come back to my Lambda function here, I can add a trigger, and the trigger says this is what triggers the Lambda function. You can run a Lambda function manually, but triggering it is normally what happens. Lots of triggers here. The ones that I mentioned, Cloudwatch Logs, when log files get stored in Cloudwatch, you can trigger a Lambda function to monitor it. Dynamodb, when data updates in Dynamodb, you can say, oh, what's changed? Should I pay attention? I've got an example for that coming up soon as well. SNS, our simple notification service. When you send a notification to that, it can trigger Lambda. And there's also a whole lot of third-party integrations built in through EventBridge. So Lambda can, those services can trigger Lambda functions. But I'm going to use SQS, and it says, which queue do you want in SQS? And I'm going to use the Brad's queue. And it's as simple as that. I hit save. I have my justlog function that will simply print the event that is passed into it. So if I go to SQS now and send a message to this queue, dev oopsie says hello. And I send the message to the queue. That gets added to the queue. Lambda checks the queue, retrieves the message, processes it. Once it's finished, it will delete the message from the queue. So if I have a look at my queues, it will probably say that there is no message in the queue because it has already been processed. Let's go back to the Lambda function. If I want to see what happened, I can go to this monitoring tab, and it can tell me if how many times the functions run, etc. But I'm going to click this link called View Logs in Cloudwatch. And it takes me to Cloudwatch Logs where I have debugging information for my particular function. And here I have a link. I just click, and here is the event record. So what I was saying before is this thing is simply printing for debugging purposes. You normally don't print for other purposes. It prints the event, and the event that came out of it is this thing here, and you'll see it says devopsy says hello. So that SQS message was passed through Lambda. Lambda could then react and do something on it. AMD, hey there, where can I find some info about this project? So I'm demonstrating Lambda. Thank you everyone for joining us today. We are looking at serverless functions using Lambda on AWS. I'll give you lots of examples, give you an overview of how you can use all these things. So Triggered. Oh, one thing I should mention is some people say, what's this silly name Lambda? Where did Lambda come from? It's the what letter of the Greek alphabet? Has anyone done their? It's the 11th letter of the Greek alphabet. Fantastic. But in computing, Lambda is a name for a term for an anonymous function, a way of saying here is some code to run, and once you finish with that code, that function, you can throw it away. You don't need it anymore. In the same way, the AWS Lambda servers can fire up, run some code, and disappear. So it's from Half-Life. So now I used the term serverless before. What is serverless? Serverless computing is a cloud computing execution model in which the cloud provider runs the server and dynamically manages the allocation of machine resources. Pricing is based on the actual amount of resources consumed by the application rather than pre-purchased units of capacity. It's a form of utility computing. So guess what? It still runs on servers, but those servers are ours. AWS runs the servers. You give some code, you say when it should trigger that code, and you just pay for the few seconds or fractions of a second where that code is running. And it works amazingly well in many different situations. A Lambda function can run for a maximum of 15 minutes, though if you're worried about it running that long, it's probably not a good use case for Lambda. Go and use containers or EC2 to use long-running functions. Typically, things that run under a few minutes are great for Lambda. Okay, let me give you another example. This is quite a fun example, which we use in our architecting course, if you ever come to an AWS training course. I have a bucket here, an S3 bucket called inventory, and I have an inventory management system. And my inventory management system has a dashboard. This dashboard is a page served directly out of S3. In the background, it logs in using Cognito. Or AWS Cognito is our service which does authentication. And so it's connecting the back end and saying, I want to log on and I want to retrieve some inventory information from Dynamodb. And actually, I should show you a pretty picture of what goes on here. Quick Labs. I will go. Yeah, excuse me a moment. I will retrieve a lovely diagram which will explain what is going on here. Sorry for staring at nothing here. And fantastic. This will do nicely. So the way this application works is there is a dashboard application that is showing the inventory. It's pulling the inventory from Dynamodb, which is our NoSQL database service. So again, this is a serverless database in a way. You can just store data. You don't have to run your own server. And what happens is a user can come along and upload an inventory file to S3. And just like we saw, S3 can trigger a Lambda function. In this case, the Lambda function will read the information from the S3 file and store it in Dynamodb. We can then go to the dashboard, which logs in via Cognito and updates the information. If all these words are confusing, don't worry, as long as you understand the general trend of what's happening. So someone uploads a file, triggers Lambda, loads it in a database, and allows us to view what's going on. Let's have a look at that bit so far. So I have my S3 bucket called inventory. I will upload a file into here. I have some inventory. Let's go for Springfield, home of the Simpsons. And I can upload a file here called inventory Springfield. If I now go back to my inventory page and refresh, we can see that it is loading some information about inventory levels in Springfield. So I put a file in S3, triggered a Lambda function, loaded information in Dynamodb. Go back to the diagram, upload S3, triggered, load in Dynamodb. To prove that, I can go into Dynamodb. Are Lambda functions really containers? Somebody's asking. Yes, behind the scenes, every Lambda function is running on a bigger server, but it's a virtualized instance. It takes fractions of a second to deploy, depending on your language, and we take care of all that for you. So each Lambda function is isolated from every other Lambda function. So here I have a table in DynamoDB called items, and we can see I have my Springfield items loaded in here. Let's upload another file maybe. This time I will upload a file from Calcutta. It has uploaded it. If I go back to DynamoDB and refresh the page, we can now see that Calcutta information has been loaded in there. If I go back to my inventory and refresh, we now have data from both Calcutta and Springfield. How do we do that so far? There's more, but have a look at that. Here it is. This is the inventory page, HTML stuff, and you'll see behind the scenes, it goes off and connects to DynamoDB, retrieves the information from DynamoDB, and then it uses a library to do some graphics on there. So the web page is basically talking to DynamoDB that has been loaded by Lambda. Is this Django? No, this bit is HTML, and the code behind the scenes I'm using is Python. I could show you that as well. Have a look. Functions, load inventory. The little function I've got. And what it does is it says, hey, when the Lambda function is triggered by the upload to S3, extract, just like the other one, the name of the bucket and key, the object that was created. It will then where have we got download. It will download the file to the local disk. It will loop through the file as a CSV file and call put item on DynamoDB. And when it's finished, if it's it's not deleting. Here's a little tip for you. It's saving a file called inventory.txt. I'll talk a little later about container reuse. And if you store files in the temp directory, they can be available later on as well. This is great because you might want to cache some data stored on the server, but it can also lead to problems if you forget to delete files afterwards and the disk can fill up. We'll touch on that a little bit later. So that is how the data is loaded into DynamoDB. But wait, there's more. I also have another Lambda function, and this Lambda function is triggered by DynamoDB. And what it does is every time DynamoDB updates, the Lambda function looks at the inventory totals in that database. And if it sees something with 0 inventory, it sends a message to SNS. So let's have a peek at the function here. I've called checkstock. So this one gets triggered based on DynamoDB updates. So in this case, the event comes through and it says, hey, for each record coming through in the event, which is a DynamoDB record update, DynamoDB can tell me what my old version of the field was and what my new version of the field was, so I can see updates. Yeah, this is like an e-commerce application, Vish. Anything you procode in a traditional thing can be done with serverless, maybe, but it's event-driven. So instead of an app sitting there forever just waiting for something to happen, it's turned around. When something happens, the Lambda function gets triggered, it does its little bit of work, and then turns off. And you only pay for it when it's running. So here it is. It's looking through the messages. If the inventory is 0, it creates a message to SNS and says, I've got no inventory alert. I've got nothing left in here. If I go to my Amazon SNS topic, so Amazon Simple Notification Service is a great service for sending notifications. So in this case, Lambda is sending a message to my no stock topic. You can then subscribe in SNS. So to give you an example, in SNS, you can subscribe to receive a message via HTTP, to receive an email, push a message into a queue. SNS can trigger Lambda functions as well, or you can send an SMS to your phone. In my case, I have a subscription here called Lambda Inventory. And what this is doing is it will send an email message to my Mailinator. Mailinator is a great website if you want to do test sending of emails. And the way it works is you don't even have to create a mailbox. You can just send to a random address at mailinator.com. And in this case, I sent to Lambda Inventory. And if I go there, I can see the messages that were sent to me. In this case, I uploaded 2 inventory files. If I read the emails, I can see that Calcutta is out of stock of this particular device. So Mailinator, great service just for sending and receiving test emails. good for anti-spam if you need a temporary email address as well. They have a price, it's free, but they also have a pricing tier if you want to do automated testing against it. So if your system sends emails and you want to get them back again and find out if they were sent correctly. So that's mailinator.com. So that's how my whole thing worked. Uploaded the file, uploaded Dynamodb, made the data available to my dashboard. Another Lambda function looked if there were anything out of stock, sent a message to SNS, and that can send out an email or a message to your phone. Yeah, pretty neat, eh? So many things you can do with Lambda. The whole idea is think of the event that triggers something and then figure out what you want to do is the main key. Now, I showed you a little bit before, but I'd like to dive more into some of these monitoring type things. So these monitoring graphs can show me how many times my function was invoked. Here I uploaded 2 files, so I can see my function was invoked twice. If I was to change this time scale, let's go back for a day, you can see some, I was testing it yesterday and invoked it 6 times. I can see if any errors came through. And if any errors came through, I can jump into Cloudwatch Logs. Cloudwatch Logs, any errors or things that were printed from my function are listed in here. So there, it's in reverse time order. So I'll click the top one. And I can see here, I'm debugging. I'm throwing out the event that was received from Dynamodb. So Dynamodb is saying, hey, here was an item in Calcutta that came through. When Dynamodb sent that through, it's saying, hey, I'm sending you old values and new values. So if something updates in Dynamodb, it can say, oh, your bank balance was $100, it's now $120. You can pass that through to Lambda. And here's my message that Lambda was sending through to SNS. Vish, you feel that Lambda's pretty clean. It's a different way of working. This reminds me of back in the early days of Macintosh. If any of you are back there, my friend David is watching this, so he'll remember. In the old days, computers used to say, what command do you want to run? And so you might say create user, and it says, what's the name of the user? The Mac turned everything around by having fields on the screen. You could click in the username, you could click in the address. When you click the create button, it triggers an event. And so the Macintosh is totally based on, and Windows now, is totally based on event-driven architecture. Rather than asking for sequential things, it goes, oh, did someone click there? Did someone type a key? Did someone click the close button? Same thing for Lambda. It's an event. It triggers some code. The code does whatever you want to program, and then it quits. How's the learning curve? The learning curve is very simple because it's your standard programming language that you know and love. If you are used to programming things in AWS, then it's exactly the same code that you would normally use to connect to AWS. So over successive weeks of Developers Let's Code, we will be showing you how you can code against other services, such as our machine language services. Is it modeled for your controller? It's not really. Something, you can have a web page trigger a Lambda, and I'll show you another example of that coming up. And Lambda can return a response to your web page, but it's not necessarily a user thing that's triggered it. It might be that an email has come in, and we have a service called our simple email service. When an email comes in, it can store that email in S3, trigger a Lambda function and say, hey, there's an email over there for you to process. The Lambda function can read that email and then process the contents of that email in some way. So it's more a event-driven data processing, timey-wimey type thing. Hey, Contra from Argentina, good to have you on board. RDS proxy sounds good with Lambda. Yes, I haven't used RDS proxy either, so I'm not going to comment on that one. So many things to learn. I mentioned before about pricing. More examples coming up, but I thought I'd mention a few things about pricing. We have a free usage tier on AWS, and the first 1 million requests every month is free. So Lambda is often invoked thousands of times a day, even hundreds of times a second. And you only pay for what's used. So whether you invoke the function once a month or 100 times a second, you only pay for what you use. It's really great that way. And the way Lambda works is, first of all, there's a request cost. I'm going to go to Sydney because I'm based in Sydney. It's still showing prices in US dollars, but it's for the Sydney region. 20 cents per million requests. That means if you do 1 billion requests, you could be up for 20 cents times 1,000. Oh dear, $200 if you do 1 billion requests. And this is the hard bit to understand. You are then charged for how long the function takes to run, and it's based on time and the size of the function. We measure the size of the function in memory. So if you say I want 128 megs of memory for that function, then every 100 milliseconds costs you this little bit of thing. If you want to multiply that by 4, the cost is times 4. So when you create a function, let's see if I can find one down here, you can allocate a certain amount of memory, and you just slide this up. And as you increase the amount of memory that you're giving that function, you are also getting more compute behind the scenes. Just like EC2 scales up both RAM and CPU at the same time, Lambda also scales it up. But you just choose memory and we take care of the compute for you. So if you choose twice as much memory, twice the cost, because the cost is charged on the size of the Lambda function times the amount of time that it ran. Let's have a look at a few questions here. Cold start issues. We'll come up with some things about cold start when we talk about provisioning. Hold that question for a moment. As to pricing of Lambda, Raj asks, I understand it's based on the number of requests. So what if my Lambda trigger performs heavy computational stuff? So you can vary the size of your machine. So heavy computation, you could give it more RAM and therefore more compute power, which means it will run faster. Or you could give it less and it might take longer to run. So it works out pretty much the same. Maximum time of 15 minutes. So there's a timeout here. I can say 15 minutes and it says, oh, maximum is 15. I can set it to exactly 15. It's happy. If I try to set it to more, it doesn't work. So Lambda is not the perfect environment to do heavy duty computational type things. Maybe you can break your task down to smaller bits and trigger lots of Lambda functions for them to work in parallel. That's a very popular thing to do, much like Spark and Hadoop do. Is it a container running behind the scenes? Yes. So Lambda is a containerized service where we provision the container. We load your code. You can actually upload a zip file with a whole lot of files that are in there. And we will load all of that. We will trigger your function. When the function ends, we stop it and we bill you for the amount of time it ran. I'll give you an example of that in a moment. Center is saying, here's a link, a blog about using microservices. Fantastic. You can have a look at that link there. So actually, the pricing is that simple. Number of times it runs and then how long the function runs. But we have another concept here. And this is, you can configure some concurrency for a Lambda function. I'll put this link in the chat. So giving it more memory means it runs on a higher tier instance, asks Brads. Yes, effectively behind the scenes, it's provisioned on a larger box. So you just tell us the memory, but it also scales the compute, and the price is included in both of those. So a Lambda function by default can run 1,000 concurrent Lambda functions. So if you throw 2,000 at us, it'll run the first 1,000, and as some of them stop running, it will run more. You can ask for an increase in that concurrency, but it's put there just to protect you a little bit in case you have some runaway services. You can also say, hey, of all of the functions that I can run, I might have several functions and I don't want those functions competing. It's a bit like at home. If you're watching movies and doing Skype calls and all that, your bandwidth is a bit limited and you might want to say, oh, I want to give more bandwidth for my telephone calls. Same thing with Lambda. You can ask for reserved concurrency that says this particular function, my production function, should receive plenty of concurrency so that it always runs, whereas my dev function, the limit might be a little bit lower so that occasionally it can't run everything in parallel. It will wait until there is enough concurrency available. So you can control, first of all, how many maximum concurrent functions can run, and of that, how many are devoted to each individual function. We also have the ability to do provisioned concurrency. So Brads or somebody asked about startup time. Gautam asked it. How to solve cold start issues with Java Lambda. So some languages run very quickly. When you invoke them, they just get going. Java has a Java virtual machine. It takes a bit of time to get going and configure. And the problem with that is when you trigger the Lambda function, it might take a second or two before it's up and running. That might be fine for some use cases, but not for all of them. So we fairly recently introduced this concept of provisioned concurrency. And what provision concurrency does is it pre-warms a number of Lambda functions, gets them ready to accept traffic. So when they're triggered, they can start processing that straight away. The downside is there's a cost involved because we are provisioning that infrastructure always available for you so you can run it very quickly. So in this case, we can see the production one has a provisioned capacity down the bottom, which means that many will run. If you occasionally go higher, it will create more containers so you can run there, and maybe some other functions have a lower reserve capacity. What's the max concurrency value that can be set? Maximum. AWS limits Lambda. Let's find out some quotas. So 1,000 concurrent executions, but you can increase that. You can upload libraries such as pandas, NumPy, PHP libraries, etc. So you can preload information in Lambda to have it automatically load with your functions. So we give you 75 gigs of storage space, and you can get up to 3 gigs of memory. You can run for 15 minutes. We also have a thing called burst concurrency. I think one of those pictures might have shown it here. No, here it is actually. So if you have a certain amount of concurrency, we do occasionally let you burst higher than that. So it's not like we severely limit you, but you can't consistently burst higher than that. So we allow a bit of flexibility within there, and you can go over your provisioned concurrency. We'll fire up some more things beyond that as well. So we've got a certain amount of concurrency, invocations, what we're saying, what's the max concurrency? I'm not too sure what the total maximum is, but you can request that that limit be increased. The way you can do it is go into your quotas, service quotas section in the AWS console. I can type in here, I want Lambda. And these are lots of those things in there, concurrency. Here's my concurrent executions, 1,000 per second. Yes, it is adjustable. I could just come in here and request an increase. We'll even show you a graph of how much you are consuming at the moment. So nice and easy to increase there. Is it a soft limit of amounts of Lambdas per account? The number of Lambdas I don't think is a problem, but it's the running Lambda functions that are the limit. Can you monitor alert when a Lambda is getting close to its allocation? Yes. Cloudwatch metrics. Cloudwatch metrics for Lambda. Monitoring functions. Not what I want. Working with Lambda function metrics. Concurrency. Using concurrency metrics. So we have all of these things. Number of concurrent executions, provisioned, unreserved, so the amount that you've got extra, and I think it also breaks this down per function, so you can get lots of information out of Cloudwatch to see what your functions are running. Now, someone also asked about container reuse. So behind the scenes, we provision a container, put your function code in there, and execute it. So when Lambda executes your function, I'll link this page in the chat for you. When Lambda executes your function, it provisions and manages the resources needed to run your Lambda function. When you create a Lambda function, you specify information such as the amount of memory, the execution time you want to allow. When it's invoked, Lambda launches an execution context. Based on the configuration settings, it's a temporary runtime environment that initializes the external dependencies of your code, like the Java runtime and all that. This affords subsequent invocations better performance because there's no need to cold start or initialize them. So let's say you invoke a Lambda function once, it creates the environment, runs the function, and then freezes. Then, if that function gets executed again, it unfreezes the environment, triggers the execution, and runs it again. And the great thing is, whatever you did to initialize the environment has already been done, so it doesn't take that additional time. After a Lambda function is executed, Lambda maintains the execution context for some time in anticipation of another Lambda function. It could be minutes, it could be hours. The more your Lambda function gets used, the more it will be kept around. In effect, the service freezes the execution after a Lambda completes and thaws it for reuse. The execution context reuse has objects declared outside of the handler function hang around. So I showed you some code before. Let's see if I can show you some code in here. And in this case, there is the function. So anything that works in the function gets executed, but anything you define sort of outside the function is initialization code, and that gets run once, and then the function gets run every additional time. So that's what it's saying here. Objects declared out of it can be initialized. The context gets 512 meg of space in their /temp directory. So sometimes people ask me, I want to write a function that will grab a zip file from S3, unzip the files, and re-upload them S3 in a decompressed format. So this can be a problem if you need more than 512 megs of disk space. It is now possible to mount EFS, the Elastic File System, on Lambda Functions, so you can have pretty much as much storage space as you wish. But by default, the temp directory gives you only 512 megs. So after you run a function, it's always good to delete the files from there before the next execution. And background processes that did not complete when the function ended resume later on. So the whole thing literally gets frozen. Any background process will then resume the next time you run it. So lots of interesting things in there. Let's go for another example of using Lambda. And we have this blog post out here, which is really great. And this blog post shows how you can create your own text-to-speech application with Poly. And this is designed, let's say you have you write some blog posts and you would like to provide your blog post in spoken language. And you want to create a system that can convert your text into speech and make it available for your website. So this is the way the application will work. In fact, it's so confusing. Let's just give it a go. And then I'll come back and show you the architecture. So I have a page here. This is just some HTML running out of an S3 bucket. And behind the scenes is going to do a HTML call. So what do we got here? I've got a web page coming out of S3. And when I do something in the web page, it will call out to API Gateway, which will trigger a Lambda function, which will update Dynamodb. And we've got a couple of different functions doing that. So S3 page makes an API request to API Gateway, calls Lambda, and updates Dynamodb. Let's give that a bit of a try. Let's go to a Wikipedia page, copy some text. And we'll paste that into here, and I'll say I want to have a Norwegian accent. Let's go for a nice English accent to start with. So all I do is click this button. It makes an API call to API Gateway and stores this information in a DynamoDB table. Let's have a look what else happens here. After that, it will trigger an SNS message that says, hey, there's something waiting to be processed. That will trigger a Lambda function that calls Amazon Poly, which can read in text and convert it to an MP3 file. And then it will go off and store it in S3. So if I just come in here and I say, show me all of the converted files, we have this job here, and it says that it is currently processing that job. So it has sent the message off to Poly, it's processing it, and if I'm lucky, it will come back into an S3 bucket. Is it best practice to use SNS to trigger Lambda over SQS? Oh, that's an interesting topic. So you'll notice here that one Lambda function, instead of directly calling another Lambda function, it sent a message to SNS. This is loose coupling, and the idea is maybe something else also wants to be notified when there is a new post that comes in. And because it's in SNS, it makes it easier to fan out and go to multiple sources. So I know some people that, as a general rule, always trigger their Lambda functions through SNS, and that way you can, in future, add additional recipients of those messages without changing any of the existing code. Let's hop into S3 and it did not trigger my code. This provides an excellent opportunity to do some debugging. Live debugging. Let's see what I can do here. I said new post. So here is the Lambda function, which by the way is given to you in that that blog article. So it goes through and shows you how you can configure this whole thing, and it points you to the code that is used by this particular thing. But let's try and see what's happening here. So in this Lambda function, it is saying go to Dynamodb, grab the text to be processed, and send a message to SNS. I can monitor and debug to see if it's working. Is there a way to manually push messages from SQS, or a Lambda trigger is required? I'm not too sure what you're asking there, Nums. You can certainly manually put messages in SQS. You can manually put messages in NS as well. You can also directly invoke a Lambda function. So you can say Lambda function invoke, and you can pass some input information that it will use to process that particular message. Oh, an error occurred. Topic does not exist. That's interesting. I need to create my SNS topic. Something must have happened and I didn't create it. So I will create a topic. It's a shame because that was meant to trigger my Lambda function. Let's figure it out. My SNS topic is called, this is a really great example. A Lambda function can also be assigned environment variables. And in this case, the code within the function is saying, grab the environment variable called SNS topic, which here is called this particular topic, which no longer exists. And this makes it really easy to change sort of variables or magic numbers within your function without having to change the code. Or you might have two copies of a function running the same code, but with different input variables. So I will create a topic called new posts. And I will go to, I think what happened is I had some cleanup code running overnight that deleted the topic for me. Thank you very much. That should trigger the Lambda function called convert to audio. So I'll go to my Lambda function, convert to audio, and I've got an SNS trigger here, and it's saying it couldn't be found. So I will delete, I will fix it. Oh, it found the correct topic and it's done that. And last thing I want to do, my earlier function, reference the SNS topic, post read a new post. I'm going to fix that environment variable because now there is, oh no, in fact, it's got the same name. I don't have to change it. So let's give this another try, see if my demo is going to work. This is my second attempt. I click say it. It has now sent the request to API Gateway, stored it in Dynamodb. If I come back, it retrieves the information from Dynamodb. If I wait 30 seconds or so, I should hopefully get an MP3 file appearing here. Which would you say is the best tool to code several Lambdas? Serverless framework, SAML, Terraform. This is a topic which is probably too big for today. I'm just trying to give you the basic overview of Lambda. But yeah, there's this SAM, which is the AWS SAM, the Serverless Application Model. And this is a framework to help you build serverless applications. Rather than just writing the function, it can build everything for you and deploy it through CloudFormation. So it's a much more reproducible way of deploying a lot of your code. So I would certainly recommend some of that. Would you recommend using SSM to handle magic numbers in Lambdas? So SSM, we have a thing called parameter store and the secrets manager. So let's say your Lambda function wants to connect to, hey, this worked. Let's say your Lambda function wants to connect to a database. And to log into that database, it needs a database password. Do not store your passwords in your Lambda functions because people can come along and see your passwords. Don't store them in the environment variable either because people can see the environment variable. Instead, you can use the secrets manager. It's secrets manager, which is very similar to the parameter store. And the secrets manager is a great way to store secrets and control who can access it, and you can say, oh, that Lambda function is allowed to access this secret value. You can then retrieve the password and connect to services. So yes, Secrets Manager or the Systems Manager parameter store are great places to store magic numbers and special things that will go out there. Meti asks, if something goes wrong with my Lambda function for any reason, I want to restart or reset it, how that works as it called serverless. So when what you saw there when I was trying to debug what went wrong with my program, I looked in Cloudwatch and I could see the log that came out here. Once I realized what was wrong, I went into my Lambda function and I could change the code, I could change the environment variables, and the next time that Lambda function is invoked, it will automatically be that new version. So you don't have to worry about deployment. Lambda will automatically deploy the version of the code you desire. You can create multiple versions. So you might have a current running version. You could then create another version sort of in dev. Once you're happy, you can release that into production. And we have something called aliases. So you could say, label version 1 as production. I'm developing version 2. Version 2 has passed the test. Now move the production alias label to version 2. So there's a whole lot of ways of deploying things out there as well. So let's see what happened here. We ran this thing, and if I play it.
This is my second attempt.
So that's Joanna saying some nice text there. Let's now try a bigger example now that it's up and working. Give me a paragraph of text from somewhere. Yeah, this is fantastic. Well, that's going to be really confusing. Pizza. I like pizza. Let's grab some information about pizza. Put that in our code here. I will say I want a nice Italian phrase here. I click say it. What's happening? I submitted it, trigger the Lambda function, put in Dynamodb, send a message to SNS. The Lambda function then pulled the information out of Dynamodb, sends it to Poly. Poly provides back an MP3 file that is stored in S3. And if I'm lucky, that will come through. Fantastic. And now I play this with an Italian accent.
The term pizza was first recorded in the 10th century in a Latin manuscript from the southern Italian town of Gaeta in Lazio, on the border with Campania. 4. Modern pizza was invented in Naples, and the dish and its variant have since become popular in many countries. 5. It has become one of the most...
Thank you very much. What I found is every Poly voice has a base language, and if you pass Italian to an Italian speaker, it speaks the thing fantastic. If you pass English to an Italian speaker, it comes out with a very interesting accent in there. Welsh, Icelandic. What's an Icelandic accent? That's going to be interesting. Then I should change parts of the code to be able to push the function to reload. So the whole topic of how to deploy is a bit outside the scope here. Have a look at that serverless access model. Serverless, what do we call it? Serverless SAM application model. And that can give you advice about how you can deploy some functions. How do you handle dependencies, libraries that are not included by default in the Lambda environment? So you can upload a zip file. I'll give you an example. In my resize that I did here before, I actually provided a zip file. So here it's saying, oh, the deployment package can't be shown because I uploaded a file that contained the pillow graphic environment, which allows me to resize pictures, etc. So you can create a deployment package, upload that to Lambda, and when the Lambda function gets deployed, it will install that environment for you on the Lambda function and then run your function. So yes, you can provide. Just be aware there is a limit of the amount of the size of the libraries you can provide in there. We also have something else called Lambda Layers, and a layer allows you to create code libraries and automatically include them with a function. So instead of having to include a graphics library with every function you're writing, you could create a layer with a graphics library, and then the function simply says reuse that graphics library, exactly as Dani says. All right. Something else I want to mention. We have a service called X-Ray. It can be very, very difficult to debug things when one function calls a Lambda function, which calls an SNS, which calls Lambda, which calls Dynamodb, and trying to debug that can be a bit of a nightmare. X-Ray comes to the rescue. So X-Ray is a service where you can label a process. So use X-Ray to visualize components of your application, identify bottlenecks, and troubleshoot requests. Lambda sends X-Ray traces to X-Ray. The upstream service, such as API Gateway or an application hosted on Ec2, samples the request. So as somebody might submit I want to buy something. So they submit a shopping cart, and that might go through many different services, checking is the value right, is the total right, is their credit card okay? And as they get passed between various Lambda functions and services, X-Ray will keep track of that particular transaction, so you can come back later and see the transaction in a visual form and go, oh, this particular part seemed to take too long, or maybe this part failed. So it's a great way of tracing through everything that's happening in there. It's called AWS X-Ray. And lots of services use Lambda built in. For example, we have some services. Amazon Lex allows you to create a chatbot, just like Alexa. Lex is the technology inside Alexa, where you can have a chatbot. So you could have a website where somebody says, I would like to book an appointment, please. It comes up and says, we have these appointment slots available. Which one do you want? I'll take the one on Tuesday, please. That intelligence is actually run by a Lambda function in the backend. So Lex calls Lambda and says, show me the appointment. Book appointment on Tuesday. Here is the username. We also have a service called Amazon Connect. And Amazon Connect is an IVR, a telephone switch in the cloud. And so you know how you ring the bank and you say, oh, I'd like to report my credit card isn't working. Can you please send me a new one? Amazon Connect allows you to deploy phone numbers, do automated voice response. So it can say, press 1 if you want to replace your card. And it can also incorporate Lex, so you can have a conversation with voice. And that is all done with Lambda. So instead of Connect reinventing how to code things, it's using Lambda built into the Connect service. Hey, poor noobs. The same visualization is available in step functions. Step functions. I did mention step functions, which is very relevant to this show. So step functions is the ability to chain together multiple Lambda functions. So I mentioned there that when you're buying something from a shopping cart, maybe you submit the shopping cart, you validate the totals, you check that the stock is available, you charge the credit card, you create the invoice, you tell the shipping people to send it out. Each of those can be separate Lambda functions, and step functions is a way of orchestrating that whole flow. And it can say, oh, if that worked, trigger this next step. Or if that worked, send messages in parallel out to all of our different warehouses and tell them to fill the order. So it's a state machine that runs on top of Lambda. So really, really good. Instead of doing one big complex Lambda, you say do this, and based on the result, it branches off, and it has these really pretty pictures. So we can show you workflows and saying, I'm going to run this function, this one, and based on that, I'm going to fork off here. So it's an orchestration layer on top of Lambda. How is that different to X-Ray? X-Ray is for debugging, where I can look through one particular transaction. So order number 43, show me how it went through each of the individual functions. So it's more a debugging tool, whereas step functions is a orchestration tool to say, do this, do this, do that. Whew. So we have come to the end of the overview of Amazon Lambda. Let's finish with a bit of a video, and you should understand most concepts.
When you're building applications, you want them to deliver a great experience for your users. Maybe you want your application to generate in-app purchase options during a gaming session, rapidly validate street address updates, or make image thumbnails available instantly after a user uploads photos. To make this magic happen, your application needs backend code that runs in response to events like image uploads, in-app activity, website clicks, or sensor outputs.
So remember that. It runs in response to a trigger. Something happens and your code runs.
But managing the infrastructure to host and execute backend code requires you to size, provision, and scale a bunch of servers, manage operating system updates, apply security patches, and then monitor all this infrastructure for performance and availability. Wouldn't it be nice if you could just focus on building great applications without having to spend lots of time managing servers?
Yes.
Introducing AWS Lambda. AWS Lambda is a compute service that runs your backend code in response to events such as object uploads to Amazon S3 buckets.
So we showed that several times. Uploading to S3 triggered Lambda.
Updates Amazon Dynamodb table.
Showed you that one as well. When some data was put in, the inventory was put in Dynamodb, that triggered some Lambdas.
Data in Amazon Kinesis streams or in-app activity. Once you upload your code to Lambda, the service handles all the capacity, scaling, patching, and administration of the infrastructure to run your code and provides visibility into performance by publishing real-time metrics and logs to Amazon Cloudwatch.
So Amazon Cloudwatch normally keeps metrics, what CPU is my Ec2 instance using. We have this thing called Amazon Cloudwatch Logs, which can keep the log file of your Lambda function so you can go back and debug it and see what went wrong.
All you need to do is write the code. AWS Lambda is very low cost and does not require any upfront investment. When you use AWS Lambda, you're simply charged a low fee per request and for the time your code runs, measured in increments of 100 milliseconds. Getting started with AWS Lambda is easy. There are no new languages, tools, or frameworks to learn.
So somebody asked earlier on, how hard is it to do? The answer is, if you're currently writing code that uses AWS, maybe from your own computer, you can just move that to a Lambda function. It works exactly the same.
You can use any third-party library, even native ones. The code you run on AWS Lambda is called a Lambda Function. You just upload your code as a zip file, or design it in the integrated development environment in the AWS Management Console. Or you can select from a list of function samples pre-built for common use cases such as image conversion, file compression, and change notifications. And built-in support for the AWS SDK makes it easy to call other AWS services. Once your function is loaded, you select the event source to monitor, such as an Amazon S3 bucket or Amazon Dynamodb table, and within a few seconds, Lambda will be ready to trigger your function automatically when an event occurs.
This little price up here is showing it's very low. There are companies out there that claim to have created their websites, their applications on Lambda, and they stay within the free usage tier, that 2 million requests a month and a certain amount of memory. Because Lambda runs so quickly, you only pay for what's in use. You might even fit in the free tier. So it does, not only is a low-cost service, but you might be able to run it for practically nothing depending on your scale.
With Lambda, any event can trigger your function, making it easy to build applications that respond quickly to new information. To learn more about AWS Lambda, visit...
Just ask me. How easy would it be? Sorry. Says contract to adapt a common framework like Flask in Python, Rails in Ruby, etc. Into Lambdas. Yes, that should work quite okay. You probably create a layer to import the required code within that and then use it. Mind you, a lot of these frameworks are built to create applications. For example, you might have a web server capability within Python. Flask can do that sort of thing. That is not really what Python is good. Lambda is good for. Lambda is great for doing that complex task. Think of it as a function that does things rather than an application that runs. It runs for a very short duration rather than being a long-running application. So while you might be able to use a lot of those frameworks, like I used to do Ruby on Rails. No, I did the Java equivalent, whatever it was. It's not the right framework to use for the use case, or the use case is not right for that sort of application environment. So think about microservices, little things that need to be done that can be farmed out that don't need to be part of your main application. Is probably what that's all about. So that brings us up to our hour. So I hope you've learned a little bit about Lambda out there. Most of these resources I showed you are online. You can just grab it. There's lots of examples of Lambda functions available for you. No show next week, but at the same time, in 2 weeks' time, we'll be looking at cloud security fundamentals, the basics of things you need to know about IAM, bucket policies, security groups, that type of thing. Very important. Then we'll have an episode on containers. So Docker, Kubernetes, all these mysterious container things. And a good opportunity to compare EC2 versus containers versus Lambda. They're each having a different use case. And the Let's Code series will continue every week, giving you a different insight for services. This show is aimed at people who are fairly new to AWS who want to code against AWS and use the services. Can we use Lambda functions alongside the EC2 instance? So an EC2 application could call Lambda, or a Lambda function could even trigger things on an EC2 instance. So a common use case might be workers pulling jobs out of SQS. David says, now you just want to move everything over. Yes, recode your entire application you just spent 6 months writing into Lambda. Thank you very much, and see you again in future. So thanks for joining us on Developers Let's Code. See you again next time.